You know, when you sit down to watch a massive live event like the Super Bowl or a global music festival, there's this expectation of flawless perfection. We just sort of assume that pristine, ultra high definition video will magically appear on our screens in real time.
Yeah, it's funny because we completely ignore the physical reality of how that massive amount of data actually travels, from a camera in the middle of a chaotic stadium to a broadcast truck parked miles away.
Right, exactly. And to figure out how they pull this off, we've been digging through some dense broadcast engineering manuals and a highly technical spec sheet from HDTVSupply. Welcome to today's deep dive.
Thanks for having me.
So our mission today is to understand the actual physics of how this flawless high-resolution video survives seemingly impossible distances, specifically by looking at the AJA FiDo-T12G transmitter.
Right, and the biggest hurdle engineers have to overcome here is what we call the distance dilemma. Traditional broadcast setups rely on copper cables, but copper has physical electrical resistance.
Which means it loses signal, right?
Exactly. If you try to force a massive high-definition video signal through standard copper wire, the signal degrades rapidly. I mean, it literally falls apart over a few hundred feet.
Okay, so pushing high-res video through copper wire is basically like trying to pump thick syrup through a really long pipe. The physical friction eventually just kills the momentum.
That is a great way to visualize the physics at play, yeah. So to solve this, the AJA transmitter takes that heavy electrical video signal specifically up to 12 gigabits of data per second.
Which is what the 12G in the name stands for, I assume?
You got it. So it takes that 12G signal and it physically transforms that electricity into pulses of light. It then shoots those photons through a single-mode fiber optic cable.
Oh, wow.
Yeah, and because it's light traveling through glass, there is almost zero friction.
Meaning it just keeps going? I mean, the spec sheet says this conversion allows for cable runs up to 10 kilometers.
It's pretty insane.
That is over 6 miles, or roughly 32,000 feet of flawless video transmission. It's like shouting across a crowded stadium, whereas this transmitter acts like a laser-focused, perfectly clear private telephone line that stretches across an entire city.
Without losing a single pixel of quality, yeah. That mechanism, converting electricity to light, is what gives professional broadcasters so much flexibility. Like, a camera operator can be standing in the middle of a forest miles away from the production hub.
And the signal is totally fine.
Completely fine. Because the signal is now light instead of electricity, it is totally immune to electromagnetic interference from other equipment.
Which is huge. And because fiber optic cables use incredibly thin glass threads instead of bulky copper, the hardware transmitting the signal can shrink down too, right? This brings us to the physical size of the unit.
Oh, it's shockingly small.
Yeah, this thing weighs just 0.4 pounds. It's barely larger than a deck of cards, measuring just about 4.5 inches long.
And despite that tiny footprint, it's passing full, high dynamic range video data. It even cleans up and duplicates the video signal internally.
That's the reclocked loop-through feature.
Exactly, the reclocked loop-through. Basically, it lets the camera person plug in their own local monitor right on the camera without degrading the main feed being shot miles away.
Wait, hold on. If it's constantly processing 12 gigabits of data a second and duplicating signals, how is this thing not melting in the camera operator's hand?
It really does seem like it should, doesn't it?
Yeah, I mean, in my experience, anything handling that much data, like a high-end gaming PC, needs massive cooling fans and huge power supplies to keep from overheating.
Well, it's a brilliant engineering contradiction. You would fully expect it to be a massive power hog, but it operates on a maximum of only 2 watts.
Oh, watts? You're kidding?
Nope, just 2 watts. It draws incredibly low voltage, between 5 and 20 volts of direct current, and it comes with a universal supply. So it's handling this massive, heavy data conversion, but it barely sips power.
That is wild.
Right, and it generates almost no heat. For a crew managing battery life in the field, or a broadcast truck balancing power loads, that efficiency is absolutely critical.
At roughly $1,000 a unit, I think it's $1,025, looking at these specs really puts into perspective how much invisible infrastructure goes into a single live shot.
Oh, absolutely. And it's backed by a 5-year warranty, which makes sense because you're really paying for the peace of mind that your signal is going to survive the journey.
Because when you're broadcasting live to millions of people, you simply cannot afford a single point of failure.
You really can't. You need that laser-focused reliability holding the whole production together.
It definitely changes how you watch TV. The next time you watch a flawless live broadcast, Just think about these invisible 0.4-pound boxes quietly firing heavy data 10 kilometers through glass threads.
It really is something we just completely take for granted.
It is, and it really makes you wonder, what other hidden silent infrastructure is working right under our noses to keep our modern world connected?